Good morning everyone. Today in this session let us start the unit 3 in artificial intelligence, that is expert systems. In this expert system let us discuss about what is introduction to the ES, phases in ES, architecture and the applications of this particular expert system. So coming to the introduction to the expert system, one of the main goals of AI is to understand the concept of intelligence and develop intelligent computer programs. So an example of that computer program that exhibits intelligent behavior is called as an expert system, or simply we call it as an ES. So expert systems are meant to solve real world problems which require some specialized human expertise and provides expert quality advice, diagnosis and recommendations. Actually an ES is a software program or system that tries to perform the tasks similar to human experts in a specific domain of the problem. So what is this an expert system? An expert system is a computer program that is designed to solve complex problems and to provide decision making ability like a human expert. How it is going to perform this by extracting knowledge from its knowledge base, using the reasoning and inference rules to the user queries. And the expert system is a part of AI, and the first ES was developed in the year 1970, which was the first successful approach to this artificial intelligence. And the performance of this ES is based on the expert knowledge stored in the knowledge base. The more knowledge stored in the knowledge base, the more that the system performs improves its performance. So one of the common examples of this ES is a suggestion of spelling errors while typing in the Google search box. And the next concept is phases in expert system. So to be more precise, there are some different interdependent and overlapping phases involved in building this ES, which is categorized as follows. The very first one is the identification phase. So in this phase, the knowledge engineer determines important features of the problem with the help of a human domain expert. So this includes like the type and scope of the problem and the goal and what is the objective of that particular expert system they are going to develop. And the next one is conceptualization phase. In this phase, knowledge engineer and domain expert, both domain expert, decide the concepts, relationships and control mechanism to describe the problem solving method. And coming to the next phase, formalization phase, it involves expressing the key concepts and relations in some framework supported by ES building tools. So it may consist of data structures, inference rules and control strategies and languages required for the implementation of a particular expert system. Next one comes implementation phase, where this phase formalized knowledge is converted to a working computer program initially called as the prototype of the whole system. A prototype is built in this implementation phase. And the last phase, testing phase, we know that to evaluate any performance of the expert system, at last we are going to test that one, that is whatever the prototype is built in implementation phase, that we are going to test in the testing phase, and the domain expert evaluates the prototype system and provides feedback which helps the knowledge engineer to revise it. If any limitations or if any thing is remained, that will be done in the after testing phase. So these are the 5 phases in this expert system. And the next one, just look at this. This is the architecture of an expert system, where these are the components like inference engine, special interfaces, knowledge acquisition, user interface, explanation module, and the heart of this expert system is the knowledge base, and this knowledge base consists of static databases and the working memory. So let us discuss one by one the components of this expert system. The first one is the knowledge base. So knowledge base of an expert system consists of knowledge regarding problem domain in the form of static and dynamic bases. And this static knowledge consists of rules and facts, whereas the dynamic knowledge consists of facts related to a particular consultation of the system collected by asking various questions to the user who is consulting that particular expert system. And at the beginning of the consultation, the dynamic knowledge is empty, but as the consultation progresses, dynamic knowledge base grows and is used in decision making along with the static knowledge. And coming to the next one, inference engine, which is also known as the brain of the expert system. Why? Because as it is the main processing unit of the system, and it applies inference rule to the knowledge base to derive a conclusion or deduce new information. Just remember the predicate logic or first order logic, there we are going to use write the inference rule. The same we are going to use in this knowledge base, and it helps in deriving an error-free solution of queries asked by the user. So with the help of this inference engine, the system extracts the knowledge from the knowledge base, and there are mainly two types of reasoning mechanisms that uses this inference rule. One is called as backward chaining and other one is called as the forward chaining. So this forward chaining, it is a strategy of an expert system to answer the question like what can happen next. Okay, that is what the forward chaining. So just an example, let us see here. There are some two rules defined by an expert system, like if symptoms are like headache, sneezing, running nose and sore throat, then patient has cold. Then rule 2, if symptoms are fever, cough and running nose, then the patient has measles. So these facts are generated in working memory by asking questions to the user whether he has particular fever, running nose or cough, etc. So in forward chaining, we start with the facts given by the user and try to find an appropriate rule whose if part is satisfied and subsequently the then part is concluded. That is what the forward chaining in this inference engine. And then backward chaining. It is with this strategy an expert system finds out the answer to the question why this happened. Okay. So it will start with a list of goals and works backwards to see if there is data which will allow it to conclude any of the goals. So in order to satisfy the goal called cold, like earlier example, the inference engine will select a rule with conclusion as cold and will try to find the facts that the if part of the role, whether the user has headache, sneezing, running nose and sore throat. In this way, the inference engine using backward chaining tries to prove conclusion of the rules one by one until it succeeds or the rules are being exhausted. That is what this backward chaining. Then one more component of this expert system is knowledge acquisition. So in this, knowledge present in an expert system may be obtained from many sources like textbooks, reports, some case studies or empirical data and domain expert, which are these are the prominent sources of this knowledge. So what this knowledge acquisition model allows the system to acquire more knowledge regarding the problem domain from the experts. So interaction between the knowledge engineer and the domain expert involves prolonged series of intense systematic interviews or using a questionnaire. They are going to have a questionnaire to get expertise knowledge. Okay, and there is one more component called case history. Just it stores the files created by the inference engine using the dynamic database and is used by the learning module. And the next components comes to the user interfaces. It allows user to communicate the system in an interactive manner and helps the system in creating the working knowledge of the problem that has to be solved. So here the function of the user interface is to present questions and information to the user and supply the responses of user to the inferences engine. Okay. So and the responses of the user may or may not be restricted to a set of possible legal answers. That means whenever the user enters an illegal answer, the user interface informs the user that the answer is invalid and prompts the user to provide the correct answer. Even that such cases also will be taken care by this user interface in an expert system. See, just this is a dialog module of a user interface, like we are interacting with the system. System is asking like, do you have fever? User is going to respond like yes. Do you have sore throat? No. Do you have cough? And are you suffering from nose? Yes. Are you suffering from headache? No. Like this, we are once we interact with an expert system, this is what the dialog module of a particular user interface is going to provide by an expert system. So next one is the explanation module. So this most of the expert system has explanation facilities that enable users to query the questions like why it asked some questions and how it reached some conclusion. So these modules generally we call it as the how and why. So these two sub-modules, how tells user regarding the process through which the system has reached a particular solution, while the why sub-module explains to the user the reasoning behind the arriving at a solution to any particular problem. So thus providing this explanation facility in a system involves at least recording the rules that are used in drawing the conclusions. So this is the explanation module, the same like earlier user module. So the system and user, but it will give us at last conclusion that this the questions what the system has asked and what the answers you have answered, then it will give some solution. Here you see, I can infer measles using the rule. If symptoms are fever, cough, running nose, then patient has measles. Then for your particular statements what you have given, you have measles. Then the user is asking how. That is how the module. Then the system will answer like, since you have a fever, running nose and cough, there is a rule like if symptoms are fever and these things, then patient has measles. So measles is concluded for you. That means even if we ask question why you have giving such answers, our expert system is going to give the solution for that particular question what we asked. So this is what the explanation module. Next one, special interfaces. Special interfaces may be used in expert system for performing specialized activities such as handling uncertainty in knowledge. Means when we are not sure about the particular problem, that comes under uncertainty. So even that will be taken care by the expert system by using some special interfaces. Okay. Now let us see the participants in expert system developments. There are three participants are there for developing a particular expert system, and what is their role. The very first one is domain expert. He is a person or group of persons whose expertise and knowledge is taken to develop an expert system. Yes, to develop an expert system, first we need one domain expert. So he is the one of the participant in an expert system. Next one is knowledge engineer. He is a technical person who integrates knowledge into computer systems. Okay, we have some knowledge is there and it has to be integrated into the system. That will be done by the knowledge engineer. And end users, we know that end user, we are the end user. That means it is a person or group of persons who are using the expert system to get advice which will not be provided by the experts. If we don't want to go for a particular person, and if you want to make use of any computer system with the help of expert system, we can get some solution by using this expert system. So these are the three participants: domain expert, knowledge engineer, and at last end users are the participants in expert systems development. Next one, let us see, already we have some traditional systems. Why we are going for this expert system? So let us see the differences between traditional systems versus the expert system. So traditional system, knowledge and processing are combined in one unit. But whereas coming to the expert system, knowledge base and the processing mechanism are two separate components. That is what the first difference between these two. The program does not make errors, but the expert system may make a mistake. Okay. Next, the system is operational only when fully developed, but the expert system is optimized on an ongoing basis and can be launched with a small number of rules. Even though some particular point of thing is completed in expert system, we can make use of this expert system. But whereas coming to traditional system, it should be fully developed, then only we can do some operations with the traditional system. Step-by-step execution according to the fixed algorithms is required. Whereas coming to the expert system, it is done logically and the heuristically. Next, it needs full information, but coming to the expert system, it can be functional with the sufficient or insufficient information. Next, why expert system? Why we have to, even though we have domain experts in many fields, why a particular user has to go for this expert system? Let us see what are the reasons why we use this expert system. So these are some of the reasons why we are using this expert system. Let us discuss in detail why these reasons cause it to use an expert system. See, before using any technology, we must have an idea about why we are using that technology, and hence the same for this expert system. Although we have many human experts in every field, then what is the need of this developing a computer based system? So let us discuss. There are some points that are describing the need of this particular expert system. In that, the very first one is no memory limitations. That is, it can store as much data as required and can memorize at the time of its application. But whereas coming to the human experts, we have some limitation to memorize all things at every time. Okay. Next one, high efficiency. If the knowledge base is updated with the correct knowledge, yes, of course it provides a highly efficient output, which may not be possible for a human. Then expertise in a domain. See, there are a lot of women experts in each domain and they have different skills, different experience, and it is not easy to finally get the output. But if we put all the knowledge gained by different women experts into one expert system, then it provides an efficient output by mixing all the facts and the knowledge. Then not affected by emotions. This is very important. The systems are not affected by human emotions like fatigue, anger, depression, anxiety, etc., which we have, a human is going to suffer from all these things. So hence the performance remains constant for a particular expert system. Then high security. These systems provide high security to solve any query. Then considers all the facts. To respond to any query, it checks and considers all the available facts and provides a result accordingly. Okay? But it is possible that a human expert may consider some facts, may or may not consider due to any reason. Then regular updates improve the performance. So whatever the system we develop, whether it is an expert system or some other system, compulsory every time there is an updation. So in the same way, if there is an issue in the result provided by expert system, and if we can improve the performance of the system by updating the knowledge base. If we just update the knowledge base, automatically it will increase its performance. Then advantages of expert system. These are highly producible and they can be used for risky places where the human presence is not safe, and error possibilities are less if the KB contains correct knowledge. And these performance of these systems remain steady as it is not affected by emotions, tensions or fatigue. And they provide a very high speed to respond to a particular query. So even though we are developing, we are dependent on system, but still there are some limitations. That is, the response of the expert system may get wrong if the knowledge base contains the wrong information. It cannot produce a creative output for different scenarios, and its maintenance and development costs are high depending upon the application. And for each domain we require a specific ES, which is one of the biggest limitations, and it cannot learn from itself and hence requires manual updates. And these are the applications like in designing and manufacturing, in the knowledge domain, in the finance domain, in the diagnosis and troubleshooting of the devices. So these are some of the applications of expert systems. Thank you.